In higher dimensions, the intuition kind of breaks down. So when we move into R4, R5, and so on. What does it mean for something to be in 4 dimensions, for example? This is why we need to be very painstakingly careful when defining the properties of a vector space. However, you will find, in terms of doing technical calculations, nothing really changes in higher dimensions at all. So what have we done so far? We've introduced the trivial vector space, 0, and we've talked about the real vector space. Now the other space that we're going to work with is the complex vector space. But a quick caveat before we get into that. You'll find that as we get deeper into the maths, that our ties to reality are weaker and more tentative. It's going to get harder and harder to give ourselves intuitive links to what different mathematical concepts are about. Let's take a recent example. What does the vector space R4 really mean? The answer, it's very difficult to give an intuitive or to picture in your head what R4 might look like. And so to some extent you just have to trust and follow the maths. But what we can do, if you have a very strong intuitive as well as intellectual understanding about what is going on with all the steps that we've taken already into R3 say, then that step into R4 isn't such a big or a logical one. For example, you may tie your understanding about R4 to being some extension of the idea of R1, R2, R3, or how things work in a vector space generally. In this course, we made a special effort to focus on the intuition. What's an intuitive understanding of vector spaces say? The reason for this is that we're going to be dealing with a lot of concepts that are going to seem foreign and bizarre. And so it's important you don't get lost in the calculations, the methods, because if you do, you can then make mistakes without realizing it. We have links on the side of each lecture where you can go and review ideas again and again until you become comfortable with what they mean. And I really recommend that you take the time to review different links. The reason is that in this maths course we go over the same ideas over and over again. So in some ways it's simple because there's a lot of repetition, but in some ways it's difficult because if you don't understand what those repeated concepts mean, then you can get lost very easily. Okay, that's enough on that. The main thing is try and keep your head above water at all times. And so if you forget a particular concept, take time to remind yourself what it means. Everything builds on previous things we've done already, so make sure that the foundations are really strong. So regarding complex vector spaces, well, complex vector spaces are a lot like real vector spaces. The difference is that the elements of the vectors are complex numbers. So just like with the real vector spaces, we can deal with complex vector spaces. It's difficult to imagine a complex vector space. What's the intuition here? The easiest thing to do is to tie them to understanding of real vector spaces. In many ways they are similar, but for now the key takeaway is just like real vector spaces, you can also have complex vector spaces, and in many ways these two spaces kind of behave in the same way. The key difference for now is that vectors in a complex vector space are made up of complex numbers. So to give you a quick example, e.g. in C3, a complex vector might be 1 plus I, 0, 3 minus I. Right? So it has a similar sort of form to a vector in a real vector space. We should also deal with even more exotic vector spaces, e.g. the set P of all polynomial functions is a vector space, and so is D, the set of all functions that have derivatives of all orders, or the set L squared of infinite sequences whose sum is finite. These vector spaces will seem very alien and bizarre, but we're introducing them now so you can understand that vector spaces can be exotic and wild, but also so that you see that in many ways they are just extensions of vector space, stuff that we already know. More about that later though. In the next lecture we talk about the mathematical concept of linear independence. For more on that, stay tuned.